bringing up a lot of points here, but you mentioned the ERVs in your opening. So I was curious if you were aware of the endogenous retroviruses and the functions that are associated with them. Take your time. Take as much time as you need, David.
Okay, 1 second. Let me pull up my notes here. All right, where are my notes?
Even before, because are you familiar with the fact that this so-called quote-unquote junk DNA, David, it can actually modify the way chromosomes, right, the packages of DNA are organized, thus changing the way the DNA functions. So, you know, this prediction of created heterozygosity based on genome functionality, the trajectory is very, very strong for genome-wide functionality. And I'm just fascinated by the endogenous retroviruses and other classes of these.
I think ERVs are fascinating. And yeah, I am aware that there are some quote-unquote function to it, but I think that it doesn't really matter in the long run if there are endogenous retroviruses or retroviruses that have to be inserted into the cell that gets passed down. I still think that's solid evidence of that the the ERV got passed down through evolution and common descent.
Well, here's the thing, though. It's not just a few of these ERVs that are functional. Literally, these endogenous retroviruses, they have crucial functions in helping to regulate genes and even determine cell type. So a lot of the evolutionists, I've debated a biologist, you know, they'll claim that the functions were actually co-opted. But is there any real evidence for that? David, like my question that I asked you in my opening was this. We know that ERVs and other classes of these retrotransposons accomplish many crucial functions in regulating gene expression, differentiation, development, for example. How do you fit that into the evolutionary story? Because evolutionists have always assumed that these were non-functional leftover remnants of ancient viral infections. But ancient viral infections don't become suddenly important in the placenta or in, you know, acting as DNA regulatory elements. Because we would say, and you probably got this from my opening, we would say that these ERVs, the pseudogenes, for example, these are all created DNA units of function, right? So how do you fit the data, the most updated data on these DNA elements? How do you fit that into your evolutionary story? And take your time, David.
All right, sure. So can you, I think it'll be helpful to point out a few of these sources that you brought up and actually allow me to take some time to read the whole paper.
I can share a screen if you'd like.
Yeah, sure. Please do. That'll be perfect.
As you're answering the question, I'll share screen on the papers of the endogenous retroviruses. But what's as I'm bringing it up, what's fascinating as well, David, is that there's various classes of these retrotransposons found in mice, and when they're turned off, for example, like the embryo, the mouse stops developing. That's how literally that's how important these classes of retrotransposons are in our in our genetics. So if you can see, I'm sharing screen. I'm not sure if you guys can see, but there's some papers here. Retroviral promoters in the human genome.
Here we go. Let's see here. Here we go.
Regulatory activities of transposable elements. Right here in the abstract, it says transposable elements are a prolific source of tightly regulated, biochemically active non-coding elements, such as transcription factor binding sites and non-coding RNAs. Like, we just know that the non-coding regions of our DNA, they're incredibly important to the rest of our genome. It's like they function much like the operating system in a computer, right, David? They're directing the timing, the expression and regulation, and use of the other parts of the genome. So I mean, it's just fascinating, and it's exactly what we've always predicted, as compared to evolutionists that would say that, you know, our genome is full of ancient viral infections, leftovers of ancient viral infections, or genetic mistakes, for example. But yeah, so if you're looking at these papers here, how would you fit this how would you fit this information into your, I guess, the evolutionary story? Like, for example, this one, I don't know if you can see Science News. Scientists
hang on one
identify
second. Hang on one second, Standing. David, are you with us right now? It looks like he got disconnected. If you could, on your side, connect him back up. All right, looks like we got him back now. All right, let's because I'm getting a lot of comments saying like we want to see David go through some of these. So maybe we'll just give him a couple minutes to try and give his side on some of these questions.
Yeah, sure.
Yeah. I'll leave these papers up, and like I said before many times, David, just take your time. Yeah, I know I've thrown a lot of information and questions at you. Take as much time as you need. I'll just sit back, and you can take your time in answering these challenges and questions. Go ahead, David.
All right, sure. So the first thing that I'm just going to do is just read the paper.
Yeah, if you want to read the whole papers, I can send them to you afterwards, just to avoid dead air. But I mean, you can see them all there.
I just like having a whole time to actually just read the whole paper.
Like this one's fascinating. Intronic ALUs influence alternative splicing, even redundancy in our genome. You know, that's based on amazing design. How would evolution? Because natural selection sees that which is short term. But yet redundancy, you know, for example, these redundant elements that help slow and speed processes in the cell. How does evolution build or evolve, you know, something like a spare tire? You know what I mean? These redundant elements would require foresight. How does evolution account for those types of functions in the genome, David?
Well, first, let me just finish this up real quick. Reading. Just glancing at the paper. Right now, I'm just kind of taking a step back, looking at the paper. Regulatory activities of transposable elements from complex of benefits that you cited. I'm just going to do a quick search.
All right, while he's doing that, I just want to say to everybody that's out there, maybe you've got a really interesting question or a really good stinger that you want to get one of them with. Just tag at Modern Day Debate or send in a super chat and get it pushed to the top of the list. David, you can start back whenever you get your place.
All right, just trying to find my place real quick. Just give me a minute.
Oh, it looks like the one I got is the redundancy of the genetic code that enables translational pausing. Yeah, I mean, there's so many papers coming out left and right regarding function in our DNA. It's almost hard to stay updated on it, but that's what's so fascinating about the creation model is so many of our predictions are coming true more and more every single day. You know, like, are you looking to just read the whole papers, or, you know, like you can see the...
Yeah, I personally like to just sit down and read the whole paper, just so I can get a better understanding. That's what I like to do. First thing to do is just read the whole paper. This one is really long.
Right, so maybe,
why don't we exchange papers after the debate? Then?
Yeah, and so why don't we set that aside for now until you've read it, and maybe we'll move on to another salient point.
Yeah, I think what we might do is just let me have a chance to read the whole papers that you're citing, and come back for a part 2 of the debate. Would that be okay with you?
Of course, of course. And Ed, when you read the paper, I want you to jot down, you know, how they explain, whether it's through co-option, for example, how they explain these functions, and let me know, and ask yourself too, is this philosophy or is this based on observable evidence? For example, I debated Conspiracy Cats recently, who specializes in endogenous retroviruses, and we spent probably an hour discussing this. And I asked him, I said, you know, do you have any technical paper, any real empirical data that can show us a non-functional endogenous retrovirus going from non-functional to something extremely functional in the genome? I mean, I want you to consider the fact that these classes of retrotransposons, as I talked about, David, that are found in the mouse embryo, that if you deactivate it, the mouse embryo will develop and then stop. Well, why? Because it depends on the function of these retrotransposons, which evolutionists have always assumed was junk. Now, the patterns, the nested hierarchical patterns, that's also predicted based on the design model. Of course, we're going to share more in physiology, anatomy, and morphology with a chimp than we will with an old world monkey, or than we will with a fish, for example, right? Those nested patterns are predicted on both sides. But the one key factor that can differentiate between the two models is DNA function. And DNA function is on the side of the creationist. If you wanted to move to